Okay, so this next one is actually a pretty simple concept, and some of you in the Ask Us program have done this in that lab, but even if you haven't, it's a pretty simple concept. We're going to dilute a solution down, and the vocabulary we use is stock solution. So we have a stock solution and in the chemical storage area, and we need to have a more dilute solution, so we have to dilute it down. And this is done a lot. If you're ever again a TA in a chem lab, this is kind of stuff that you're going to be doing. And so the formula is we're going to take the first molarity times the first volume, and we're going to set that equal to the second molarity times the second volume. So the volume units really don't matter. Remember, like with the ideal gas law, you had to have liters. Well, this one, you really don't. As long as this is mils and this is mils, it's okay. Or if this is liters, that's fine. Molarity, of course, will always be moles per liter. So let's just look at a couple of situations we'd have. Let's say that we want to make 60 milliliters of a 2 molar solution. So this would be very common for me to have to do if I have 4 chemistry classes, 7 lab groups. Everybody's going to need 100 mils. I want you to have a 2 molar solution. I would use this information. I would go into the storeroom, I'd grab the stock solution of 8 molar. So let's just go ahead and do that calculation. So M1V1 equals M2V2. So the question is, how many milliliters of this 8 molar solution do I need? So I don't know. I do know that I want a 2 molar solution, and I know that I want 60 milliliters of it. All right, so pretty simple. I'm going to solve for this V1 here by dividing both sides by 8. And again, I'd encourage you to do that, but you get 15, and that would be mils because we started with mils here and in mils. So it's important to understand what you're doing here when you're making this up, and it's unfortunate that we cannot do labs this year, but what you're going to do this is you're going to take 15 milliliters of the 8 molar stuff. You'll put 15 milliliters in there. Okay. Now you want to have a total of 60. So hopefully you know what you're going to be doing here is adding 45 milliliters of water. Again, the terminology is important to read the question. You're going to add 45 mils of water to that 15 mils of 8 molar hydrochloric, and you're going to stir that up, and when you stir it all up, you'll have a 60 mils of a 2 molar solution. I will add quickly that you really technically, and for safety reasons, are never supposed to add water to acid. It's always acid to water. Now this 8 molar solution is not very concentrated, but if you were to do this with sulfuric acid and a concentrated sulfuric acid or acetic acid, a glacial acetic acid, which is the most concentrated, if you add water to it, its specific heat capacity cannot handle that. You'll start seeing the bubbling going on, and you could get bubbling and splashing, so it's a bad situation. So if it's a concentrated acid, you're always supposed to add the acid to the water. Water has such a high heat capacity it can handle that. But that's a side note. Let's try one other here. So the second question here is, what would the concentration of a solution of hydrochloric acid be if 50 mils of a 2 molar solution of it were added to another 50 mils of water? So you're diluting it down by adding 50 mils of water. Now this one you might be able to just answer in your head, but let's just go ahead because they're not always as easy as one would hope. And so what we're saying here is that we have a 2 molar solution, and we have 50 mils of it. So it's important to read the question carefully, and 50 mils of 2 molar. I see people, mixing up numbers because they're not reading it carefully enough. Now, the second molarity, we don't know. It says, what is the concentration? Now, the second volume, don't just put in 50 mils of water. 50 mils of water is being added to 50 mils of 2 molar. So we have a grand total of 100 mils of solution. So this is all about solution. All right, and so to solve this, I'm going to divide by 100 on both sides. And just doing this in your head, you might have said, well, you're diluting it by half, and that's true. The second molarity is 1 molar because you have diluted it with the same amount they started with. But just go back and use that formula, know exactly the molarity and the volume of the one thing, put it equal to the molarity and the volume of the second concentration.